All right, scholars, so this is especially for B2. Yesterday lesson, so we learned about arithmetic sequence and geometric sequence. I'm just going to make it a little more easier on you. So this is the formula we use for arithmetic sequence where nth term and then k term, d is the common difference. Some of the problems that we're doing, we'll plug something for n, something for k. You're like, what is what and all that. So, the rest of the other periods, and this is how delta math did it. I just decide to use 1 for k. Then this whole thing becomes a sub n is equal to a sub 1. Instead of k, I'm using 1. It looks something like this, where you need the first term, and then common difference, and n. So really, the only nth term that you have to worry about here is n, not so much of the k. Okay? So using this, I just want to solve a few problems with you. So if you have notes out, feel free to. If you don't, that's fine. So I want to do this example 3. We already did it in class. Let a sub n be arithmetic sequence with a sub 3 is 8 and d is -3. So let me write down. We got a sub 3 is 8 and d is -3. The common difference is -3. We're supposed to find the equation of a sub n and then a sub 12. Okay? All right. Excuse me. So I know the common difference, -3, so I'm just going to plug the -3 into d. And a sub 3, I already know what that is, so I'm going to just plug that 3 instead of n here, and n here as well. Then this whole thing becomes a sub 3 equal to a sub 1 plus d, which is -3, and 3 minus 1. Are you good so far? All right. What is a sub 3 equal to? That is equal to 8. So 8 is equal to a sub 1. -3 times 2 is -6. So I just get -6 right there. Notice you only have one variable, so I'm going to add 6 to both sides. A sub 1 is equal to 14. Yay? All right. So we know what the first term is. So when I plug that a sub 1 back to 14 here, and then the common difference -3 back to here, then I get a sub n is equal to 14, the first term, 14, minus 3, n minus 1. That's what I get as a formula. Well, I need to clean up a little bit, so I'm going to distribute that -3 in. 14 minus 3n plus 3, I get -3n plus 14, and that is the equation of this arithmetic sequence for the example 3 problem. Okay, as you notice, this is a linear function, yay, with the slope of -3, and that slope always is the same as that common difference, so that's a good thing. Now let's find a sub, what did it say? A sub 12? Yeah, a sub 12. So a sub 12 is going to be equal to, you just take that 12 and then plug it into n. I got -22. Yay, we got it. Does that make sense? All right. Now what about example 4? Example 4 says a sub 2 is 7, a sub 6 is 9. We're supposed to find the a sub n again, and a sub 24. So how I did it in the class, we say like k is 2, and then like over here k was 2, n is 6. You plug it in, like so many things going on and all that. So I'm just going to stick with this formula right here. Let me rewrite it. A sub n is equal to a sub 1 plus d, n minus 1. All right. So first, I'm going to take that 2 and then plug it into my n here and here. So I got a sub 2 equal to a sub 1 plus d, 2 minus 1. Once again, instead of n, I'm putting 2 in. A sub 2 is 7, so 7 is equal to a sub 1 plus, that's a 1, 1 times d is d. You good? All right, so I got this one equation over here. Notice I have 2 variables, and I just have one equation. Do you guys know the number of equation? The minimum number of equation you need to solve the equation is when you have a 2 variable, you need at least 2 equations. So where am I going to get the second one? Well, we just use this one. Then can I use this one to plug it in? Yeah. So n is 6. So I got a sub 6 is equal to a sub 1 plus d, 6 minus 1. So I took that 6 as an n, plug it in here, plug it in, plug it in, plug it in. Okay? Then I got a sub 6 is what? 9 equal to a sub 1 plus 5d. Okay, so I got this equation from using the a sub 2. I got this equation from using a sub 6. Let me put them side by side. And look at this too carefully, folks. All right, we learned how to solve systems of equation back in Algebra 1. So when you have a two variable, we usually have like x and y. So imagine this is 7 equal to x plus y, 9 equal to x plus 5y. How do you solve it? The two method, elimination, substitution, since they're the same coefficient in the front, I'm just going to use elimination. What do I mean by that? I'm just going to subtract top from the bottom. So 7 minus 9 is negative 2 equal to, you see what I'm doing? A sub 1 minus a sub 1 is 0. D minus 5d is negative 4d. Okay, this is just elimination we learned in Algebra 1. Divide both sides by negative 4d is equal to half. So the common difference for this problem is half. Okay, all right, remember we have two variables. We just found one variable. How do you find the second one? You plug that back in to find it, right? So let me put this down over here. I have 7 is equal to a sub 1 plus d. We said d is half. Then a sub 1 must be 7 minus half is 6.5. Yay! All right, so we found the common difference. We find the first term. Then the whole thing, a sub n, must be equal to, how does it go again? The first term, which was 6.5, plus, what's the common difference? Half, times n minus 1. I just plug it back to that. Clean it up. 6.5 plus half n minus half is half n. 6.5 minus half is 6. So there is my a sub n. And then what am I supposed to find? A sub 24. Take that 24, plug it into n. That was the easy part. Then you get 12 plus 8 is 8. Okay, so that's how you do the arithmetic sequence using that only formula instead of doing with the k and n and all that. Okay.